Hi, this is a quick lesson on logic gates. What you see here on this screen is an example of a network. This network is made up of several gates, several logic gates. Over here, you have an OR gate. Over here, you have a NOT gate. Over here, you have an AND gate. And here you have another OR gate. Notice that all the gates that are AND and OR have two lines flowing into it and one line flowing out of it. This makes sense because you need two statements in order to make an OR statement, and then out comes a new statement. And so one of the things that you have to do is to be able to write a statement that represents this network. So let's start over here first, up here, okay? Here, you're feeding P and you're feeding Q into an OR gate. So clearly, it's going to be P or Q. That's going to be that part, okay? Now, we're going to go to this part of the network down here. Here you can see that P is going into a NOT gate, which means that we're going to have NOT P. Down here we have an R, and together NOT P and R come together at an AND gate, which means that we're going to have NOT P and R. NOT P and R. Okay? And then, as you can see, over here, those two things, the P or Q and the NOT P and R, come together at an OR gate. So the way that you're going to write this is you're going to put parentheses around this and parentheses around that, and you're going to connect those two with an OR, because the last gate right there is an OR. So what you see right there is the statement that is represented by this network, or it's a statement that represents the network. Okay? Now another thing that you need to know for this about logic gates is to how to determine what an output would be given certain inputs. So for example, if we have P is true, okay, and let's say Q is false, and let's say that R is true, what is the output? Okay. Well, a good way to do, so one way to do this is to make a truth table. But you only have to make a truth table using one row. A row where P is true, Q is false, and R is true. So you don't have to do all 8 scenarios because we're very specific about P being true, Q being false, and R being true. Another way to figure out the output here is to use the network up here. And so how do you use the network? Well, let's see. First of all, P is true. And so because P is true, on this line right there, we're going to write a 1. So there's a 1 right there. Likewise, we're going to put a 1 right over there because P is also over there. So that's a 1. Okay? We're told that Q is false. So over here, we're going to put a 0. Okay? And then we're told that R is true. So over here, we're going to put a 1. Okay? So we have that. Okay, so now we're going to go through the gates. Let's go through the gate up here first. A true and a false will give us a true in an OR gate because the requirement is that if at least one of them is true, then the output is true. Okay? Down here, P being 1 goes through a NOT gate, so it spits out a 0 over here. Okay? So now we have 0 and a 1 going into an AND gate. And the requirement for an AND gate is that both have to be 1s in order for us to get a 1. And so that's not the case, so there's a 0 right there. Finally, a 1 and a 0 going through an OR gate would give us a 1, because the requirement for an OR is if at least one of them is a 1, the output is a 1. So here, the ultimate output here is a 1, so that makes this question down here true. That if P is true, Q is false, and R is true, then the output will ultimately be true. Okay, so I hope this helps. Your task is to do logic 2 And now you should have enough to be able to do the last few problems. Number 6, number 12, number 13, and number 14. Good luck!